This clip is about the Decorator pattern. Before we can talk about this pattern, we need to discuss a mechanism called recursion, because this pattern relies on that. An example of recursion in the real world is the famous Droste effect, which is a picture recursively occurring in itself. This creates a loop that can go on forever, but in this case is of course limited by the image quality in the end. We can also have recursion in code. This means that a function will call itself again. Here you see an example of this. The rec1 function takes a value. If that value is larger than 0, it will print it out and then call the function again, but then with value -1. Suppose you'd call this function with the value 4. What will be the output? It will be 4, 3, 2, 1. This slide shows you how that happens. I first call rec1 with value 4. Since this value is larger than 0, it will first run the print statement and then call the rec1 function again, but this time with value -1, so 3. This function call will print 3 and call rec1 with value 2. This will call print2 and call rec1 with value 1. And this will call print1 and call rec1 with value 0. Calling rec1 with value 0 does nothing because of the condition in the if statement. And then finally each of the function calls returns and we end up first printing 4, then 3, then 2 and then 1. Let's see what happens if we switch the order of the two statements in the body of the if. So instead of first calling print and then calling the function again, we do it the other way around. What will be the output then? This is what it looks like. We call rec2 with value 4. This calls rec2 with value 3, which in turn calls it with value 2, then value 1, then value 0. Value 0 does nothing, so it simply returns. We're now back in the call with value 1, so it prints 1. Then we're back in the call with value 2, so this prints 2. Then it prints 3, and finally prints 4. The output is then 1, 2, 3, 4. Exactly the opposite of the first function example. As you can see, recursion is actually a way to represent iteration, like a for loop. The important thing to realize is that code before the recursive method call is executed in order of the recursion. So the print statement before the function call will print 4, 3, 2, 1. And code after the recursive method call is executed in reverse order, 1, 2, 3, 4. Recursion is something that occurs in many programs and is especially used in functional programming. But be careful, because if you forget to add a way to stop the recursion, you can create an endless loop. In the examples I gave, the recursive function only continued if value was greater than 0. If you would remove that limitation, the program would never stop running. So a limitation like that is necessary, or otherwise, yes, the explosions are back. The Decorator pattern relies on the concept of recursion. Let's see how it works. Here's a menu of a pancake restaurant. You order a pancake and you have a couple of options for the toppings. Of course, it doesn't end here. There are lots and lots of toppings available. You can also have combinations of toppings. You're decorating pancakes with toppings in a certain order. This is exactly the kind of structure that the Decorator pattern solves. Let's look at another example. A sales order system. We've seen this one before. Sales order can handle different tax calculations using the strategy pattern. But now we want to extend the system so that it can also print receipts. So we extend it with a receipt class that has a print method. Each receipt may be extended or decorated with various things in the header and the footer. There will be address and tax information, customer loyalty points, extra fees for importing and exporting, a discount code for your next order, or perhaps a line about special sales around Christmas, and so on. As a first solution, let's make a separate header and footer class that will be able to print all of those things. Unfortunately, it's not an ideal solution. The header and footer will now contain lots of if statements checking what should be printed. Also, the header and footer now need specific implementation details regarding taxes, discounts, and so on. This leads to too many responsibilities, weak cohesion, and too much reliance on other parts of the code, tight coupling. Is there a better way? The intent of the decorator pattern is to be able to add responsibilities to an object dynamically. Instead of having to add code directly to a method in a class, you can leave the original code intact and add a decorator to extend the functionality. You can view decorators intuitively as a chain of objects that add some new functionality to a concrete component that's at the root of the chain. In the pancake example, the concrete component is the pancake, and we decorate it with a chain of various toppings. How do you create a design for this? This is what the decorator pattern looks like. On the top, we have an interface that defines a certain operation. There's a concrete component on the left that is a basic implementation of that operation, the pancake. The decorator class also implements that same operation method, but at the same time it also uses the component via an aggregation. This is the recursive part of the decorator, and it allows for chaining them. Finally, there are concrete decorators that are again subclasses of the decorator abstract class. So the decorator has a recursive part in its design, and it's one of the few design patterns that uses a two-level deep inheritance hierarchy. Let's see how you can apply the pattern in a concrete scenario, receipt printing. If we follow the decorator pattern for this, we start with an abstract receipt class with a print method. There is a single base component, concrete component, the base receipt that prints out a basic receipt. Then, on the right, we have a receipt decorator class and concrete subclasses for each decorator. Here, there's a loyalty points decorator and an export fees decorator. The receipt abstract base class has an abstract method called print. Then, the receipt decorator class is both itself a receipt, since it's a subclass, but it also contains a reference to another receipt. This is where you see again the recursive part of the decorator. And here you see an implementation of the loyalty points decorator. It prints the number of points earned, and then it calls the print method on the receipt that it decorates. The order of these statements determines if it's a header or a footer. In this case, since the points are printed before the rest of the receipt, it's a header. In order to use the decorator, we create a base receipt object first and then decorate it by supplying it to the initializer of the loyalty points decorator. When you call the print method on myReceipt, it prints out the loyalty points and then calls the print method on the base receipt. You can endlessly chain decorators. If you call print on myLoyalReceipt, it will print out that you have earned 10 points twice, because there is a chain of 2 loyalty point decorators before you get to the base receipt. If you want to create a receipt with both a header and a footer, you create a chain of 2 decorators, 1 header and 1 footer. The order here doesn't matter, because the footer is always printed after the base receipt and the header before. Order does matter if you have multiple headers. Note that headers are printed in the order of the recursion, and footers in reverse, like the 1, 2, 3, 4 example of recursion we saw in the beginning. In the real world, you'll see decorators often used for processing pipelines. File streams are a good example of this. You can use the decorator pattern to create a stream that first decrypts the data, then unzips it, then buffers it, sends it over a network, converts it into another format, and so on. Adobe surely also uses the decorator pattern to apply a series of filters over a photo. First you crop the image, then apply an anti-aliasing filter, then a color change filter, then an image resize, then export to a PNG file, etc. You can also use decorators for debugging and analyzing performance. For example, you could use it to wrap another function and print out timing information to measure performance, or print input and output values to verify what is actually happening. So to conclude, the decorator pattern helps to extend the functionality of an object dynamically. It relies on a recursive pattern of aggregations to create a chain of objects. At the base of the chain is the concrete component that you want to extend. We've reached the end of the video about the decorator design pattern, and here you also have a decorator joke, of course. If you have any questions, feel free to post them in the Teams channel of the course. Thanks for watching, and catch you in the next one.